get through.
Without exemption.
I planned each charted course.
Each careful step.
Along the byway.
And more. Much more than this.
I did it my way.
Yes, there were times, I'm sure you knew, when I bit off more than I could chew. But through it all, when there was doubt, I ate it up and spit it out. I faced it all, and I stood tall, and did it my
So how many times have you thought that it would be better to do it your way? In fact, it's something that happens to me almost every day. For example, just this morning, I went into a grocery store because I wanted to just buy some fruit for the conference. And I need to wait until the 5 people in front of me was served. And then the guy came to me and asked me, what do you want? I said, yes, I want some more and cheese and some bananas. So he went to the place where the bananas are, and he took the ones that looked well for him. He asked me for going to the cash desk. I paid with my credit card, and I went out of the store. And I was thinking, wouldn't it be great if I could just go inside the store, pick whatever I want, and walk outside with my fruit? I think you are thinking in Amazon Go. Yes, and I'm referring to Amazon Go. And for me, it's the perfect scenario because it has 3 things. It has performance, it has freedom, and it has security. It has freedom because you can just go into the store directly to the shelves where the bananas are and pick the ones that look good for you, not for the guy. It has performance because eventually, if there are 100 bananas available and 100 people coming at the same time, each one of them can take one and go out. So you are serving 100 at a time. And it has security because you don't need to carry your credit card with you because they are knowing who you are, and whenever you walk out of the store, the amount is directly charged into your bank account. So these 3 things, freedom, security, and performance, are the 3 things that you would like to have in every tool that you use for DevOps. Unfortunately, you don't always have them. So, good afternoon. I'm Guillermo Palacio, and I'm platform engineer at Adidas. I'm also a Jenkins CI contributor. And since this conference, I'm a Jenkins certified engineer. And since I joined the company in Adidas, and I've been working with Jenkins, obviously, I've been obsessed about achieving these 3 things in our environment. Remember, freedom, security, and performance. It was not there in our installation. So were you at the SASA's keynote yesterday? How many of you have this Jenkins thing? Can you raise your hands? Don't be shy. Okay, so we have this, and we think about how can we improve this. So this is how we did it, our way. So what are you going to see in this presentation? We will go fast through the node problems that we had in our organization that maybe are ones that you are facing in yours. I will tell you what we thought it would be the desirable solution for us. And I will tell you how we implement it and how we put this into production. In this way, we learn something. And we are trying to spread this to the community, and that is the project ACID. And finally, I will show you a demo about how it is working. And one disclaimer, you are going to see UIs in this presentation. So what are the known problems that we had? The first known problem was the competition for shared resources. So at the end, we have many teams working in our instance. So we have one master, or we had one master, and many slaves with different purposes, Java builds, Docker builds. But at the end, all our teams are mainly working in Node.js, Java, so every time they want to build something, they need to go to the same slaves. And whenever someone takes one, the other team cannot see what is happening because they don't have the grants to have it. They only see that there is no executors available. We had shared permissions as secrets because although we are placing the secrets in different folders with different grants, at the end of the day, everything is in the same Jenkins master. So eventually, if there is a leak in some of the administrators' passwords, the whole Jenkins is compromised. And we have a single point of failure. It's just the same reason. If we have a greedy team getting all the resources and getting down Jenkins, then Jenkins is down for everyone. And Slack starts blinking about what is happening to Jenkins. And plugin review. This is really a headache. Whenever you want to put a new plugin into production, whenever a new team is asking you for a new plugin, and this is happening quite often because developers always want to be with the cutting edge technology, they are asking you to put a new plugin, and you need to evaluate. So you are telling them, please, let's put it into staging, let's test it, and after 1-2 weeks, maybe it will be promoted to production. And they want it for yesterday, not in 2 weeks ahead. So what we thought it would be the desirable solution, and I think it's something that you heard a lot in this conference. So having something cloud native. Because if you go to cloud, you will be able to scale easily, and you will get all the benefits of the cloud. You also want something that is horizontally scalable. Why? Because your Jenkins is on fire. So you are hitting the boundaries of your installation, of your machines. So you need to do something. And by default, by architecture design, you cannot just say, OK, spinning a new Jenkins master with the same configuration. So what you want to do is having different Jenkins masters with different purposes that can serve different teams. And having this ecosystem that you want to have someone that controls everything. Not meaning it's giving freedom. Remember, we want to give freedom, but we also want to give security, having some kind of governance. And this is really important. You want an elastic slave pool because you don't know what is the workload today. And this was also one of the key things from this morning keynote. You just want to pay for what you are using. You don't want to think about what would you need in 1 week back? So you want something that can scale if the workload increases, but that can also scale down when it's not more necessary. And this is something key for the way we did what we did, and it was minimum migration impact. We wanted to migrate for the old Jenkins installation to a new one, but we didn't want to change the user experience. We have people that is advanced in Jenkins, but we also have developers from vendors that they only know that they need to go to a UI and click a button to do the builds. Yes, we still have freestyle jobs. So we have this kind of mixed ecosystem, and we need to support without impacting them in the day-to-day work. So finally, we came up with this infrastructure, and it was in Kubernetes. Why? Because we wanted something cloud native. So if we can put the things in Kubernetes, we can scale easily. How we did it? So what we are doing is we are just creating a new Jenkins master with a set of slaves in a namespace. So each team has their own Jenkins in their namespace, isolated from the rest of the teams. And inside that namespace, you can see that we have some slaves here, slave pods. Thank you, Carlos. I don't know if Carlos Sanchez is in the room, but thanks to the Kubernetes plugin, we are spinning up slaves on demand. And these slaves are special. You can see there that there are 2 containers inside. There is one GNLP container that we need to connect to the master, modify it a little to add some features, and we have a Docker in Docker daemon. Yes, I know it's awful, but it works. So why we put that Docker in Docker daemon? I told you, minimum migration impact. Having this configuration, we can just migrate the jobs from the old Jenkins to the new one using the same shared libraries, the same functions. So do you know Docker Inside, for example? We can run Docker Inside here. So with this, we are migrating the jobs out of the box. And then if we want to improve and take the advantage of the Kubernetes plugin doing it in a different way, we also can do it. And we have this Lord instance. This is the instance that you said you saw in the previous one. It's controlling the ecosystem. It's the one that you enter to create new instances, to apply patches to the new instances, and where the Lord of our architecture. So we wanted also security. We wanted to track everything that is happening. So a part of this happening in Kubernetes, we have a Bitbucket repository and a CRUD directory server. So CRUD we are using for everything related to permissions, groups, authentication, and so on. In Bitbucket, we have 2 things. We have every single instance is synchronizing every change that is happening in their configuration to Bitbucket. So remember the GitOps. So if something happens, we can recreate everything from scratch because it's synchronized in the repository. Obviously, we will lose the build history, but that's not a problem. And we are also storing more things in the Bitbucket. So we are using Bitbucket to have the basic configuration that we need to spin up these new instances. And it was great yesterday also to hear about the configuration as code project, because we did it somehow in a different way. I mean, we started 2 years back, so that project was not in place, but we are following the same direction. So we have different repositories in Bitbucket. We have the master image-based repository. In this repository, we have the Docker file of the Jenkins masters with some modifications. I will show you later. We have the master config. Here we store the blueprint of our configuration. We have different configuration in different branches, so we can spin up new instances based on different configuration. This would be the equivalent to the configuration as code YAML files. We have the master deploy, where we store everything related to deploy the things to Kubernetes. And we have the slave image-based repository. The same way that we are modifying a little the community Docker image for the Jenkins master, we are doing so for the slaves. And we are also creating different slaves. I will show you later also how we can provide different slaves to our teams. But finally, when you deploy a lot of instances, you have 20 instances deployed, and then you want to spread a change across all the instances that are already running. So how can you do it? So we are doing it with this in this repo, this master config change set. So whenever there is a change that we want to apply to live instances, we just create the patch in this repository, go to the Lord instance, and apply the change to the instances that we want to be modified. And how we are managing all this stuff with the Active project. So Active project is a command line tool designed to create this ecosystem, to help other people to create the ecosystem from scratch, to having in their own Kubernetes clusters. This is just a dashboard about the monitoring of the cluster. For you to know that we have around 2,000 developers using Bitbucket, and currently this is outdated, but some of the instances that we are using, we have now in production. The project is available in the Adidas GitHub IO open source project, because in Adidas we have initiated the open source, and we want to collaborate with the open source community because we are benefiting from the open source, and we are placing there. We have Docker in Docker, but also we are looking into new ways of building images. We are looking into Canico, for example. There are another ones like Build and other things, just to avoid the use of Docker in Docker images inside the cluster and build natively the images in the Kubernetes cluster. We want also to move to Helm for deploying things into the cluster. And as I told you, configuration as code will be something key in the future for us. And also the cloud native initiative from the Jenkins project. I mean, we are aligned we are just going in the same way. So want to see a demo? So let's go first for how we upgrade the Jenkins version. So we have a master running in one version, and there is a new version available in the market that we want to incorporate because there are security vulnerabilities or whatever. So can you see? Sorry. Come on. Sorry, I just wanted to zoom in into, because I don't know if you were able to see it properly. Okay, so here we are. Can you see it properly? So this is the community image for Jenkins master. Just imagine that we have different tags, that the LTS Alpine, we have the Alpine one, the LTS Alpine, and we want to generate a new image to be run in our infrastructure. So we want to this master image-based repository, and you can see there that there are several branches there. So we can just create a new branch from there, and we just name it in the same way that the Docker Hub image is tagged. And automatically, in our Jenkins Lord instance, there is a multi-branch pipeline project where you can see now here, there will be a new branch building the new Docker image that will be ready to be deployed for the new instances. And so if we go into the logs of the job, you will see that we are taking the base image on the from, and we are placing some stuff. Like, for example, you heard that we are synchronizing every time with Bitbucket. So for doing that, you need to do several things, like place the SSH keys in the correct place, or we are installing plugins that are handmade. So we are placing this functionality about installing this plugin in this image, but it's based on the official one. And now we want to create a new instance. How we do it? We do it also with a Jenkins pipeline. So you can see there that we have several jobs for controlling our Jenkins as a service instances. And we can just go to the first one, that is create and deploy a new instance. So it's a parameterized job that when we run it, we just need to provide a name for the new instance. Let's call it JWorld. You can see the branch that we want to use from the config-based repo. We are using the config-based repo, as I told you. I will show you later. And we can select the branch that we want to use as the base configuration. Just telling the cluster where it's going to be run, in which Bitbucket project we want to store the new config, where the config from the new instance will be synchronized. And we provide a list of administrators for the new instance. So these people will be the ones with the freedom to do whatever they want in their instances, like installing new plugins. So they can install a new plugin whenever they want, and we are not worried about impacting other teams. So after 4 minutes, the instance is ready to be used. So what is happening here? You saw that we just triggered a job, but what is happening in the background? We will see it just now. We are going to see how we create this new base configuration from the master config repo in Bitbucket. We create a new configuration, and we use that configuration for the new instance. So if you are familiar with Jenkins, you can see here, and you will identify that this is just the Jenkins home. No, we are not storing everything, but basically the Jenkins home. But we have a slightly difference. You can see there an M4 file for the config XML, and this because it's a template. So this is the way we are doing our configuration as code. We have templates that when we create the new repository for the new instance, we modify this template with the things that are needed for the new instance. And as I told you, we have different branches. So we can select different configuration for different types of instances. So this is just basically a config file where you can see, for example, the administrators. You see here that there is a group called just instant name admin, and the instant name is just a variable that we are going to modify so the new JWorld instance will have the proper values. So we are cloning the repository or forking the repository into a new one specific for the instance, where every change for that instance will be automatically synchronized, and we are placing there the proper values for these variables. So if we go inside this repository and we see the config.xml file, you will notice there is not more an M4 file. Now it's an XML file. If we go inside and we go to the same piece of the XML that we were saying before, you can see that we modified that variable for the proper crowd group. And this group has my ID, that is Palakgi, as an administrator of the new instance. We are doing also another thing. And this master image deploy, we are creating a new branch for the new team. And in this branch, you can see there is an SSH folder. This SSH folder contains the credentials for the new instance to synchronize with the repository. And these credentials are generated on the fly for each new instance, meaning if one instance gets compromised, they can only access to their repository, not the other ones. This is common. You can see that there is a config, a public key, a private key, and we have another file. Like there is a Jenkins file there because we are deploying using the Lord instance, and this is the template for the deploy. So you can see there that we have variables for the namespace, for example, that we are also modifying every time that we are deploying a new instance. What else can we see here? I just show you how we are creating the new configuration, but now we want to launch the new instance. For that, we have also another pipeline, a job, I don't remember, sorry, now how we configured at the end, where we have the Jenkins file to deploy. So we can deploy whenever we want, providing some parameters. And you can see there that we just deployed 6 minutes ago the new instance. And if we go inside this job, that is a pipeline, you can see the steps, and we have different steps like let's get the namespace. If the namespace doesn't exist, let's go and create it. Create the secret where we store the SSH credentials that as a Kubernetes secret that we inject into our instance. And this is how we have our instance ready to be used. And that is exactly what we are going to see in the next video. So this is our JWorld instance that I just created, and I'm accessing with my credentials without configuring anything, because the configuration about the authentication is provided by the blueprint. And now I'm an administrator of this new instance, and I can start adding users, adding my plugins, or if I want, I can just create a new job. And in this case, we are going to create a freestyle project because people still use freestyle projects. Well, I would like to change that, but we need to support that use cases. So let's create a JWorld test where we will just execute a select step to see which Java we have by default and which Docker we have version we have by default. So you can see that you are using Jenkins in the same way that you were using before, and that's because of the minimum migration impact. And you can just place here a common cell, and we have done nothing to be able to do this. We just create and deploy a new instance and log in into the instance. Now we are launching a new slave. So that's why we are waiting, because we are using the Kubernetes plugin. We are launching this new slave, and we are executing inside the job. And we will see in just some seconds that the job is finished correctly. And we can go inside the logs of the execution and see that we have some Java, I think it's the 1.a, and the Docker 17.06, I think it is. And that's out of the box. And how we are spinning the slaves? We are doing so with the Kubernetes plugin. For those of you that don't know, the plugin is something that we can configure here. Basically, here we tell the Jenkins master, you have this Kubernetes cluster, and you can spin up new slaves in this cluster based on these templates. You can do it in two ways. You can do it inside your pipelines, but you can also do it in the config file. We are doing in the config file, you know why? Minimum migration impact, because then people can just use the same pipelines using the same node labels to access the same type of nodes that they were using. So here we define different templates. We have a base template, a base slave, and we define the GNLP slave for connecting, and it's based on one of our images that we have customized. And we have customized, you will see it in a minute, to add more things to the base slave. And also to install, for example, configure the Docker, to connect to the Docker in Docker daemon. The Docker in Docker daemon is a privileged container running the same pod, but we are only executing things there using the Docker client that is installed on the GNLP. So trying to make some kind of isolation. We faced some problems about the MTU. So this was no easy, but we were having strange behaviors when building Docker images due to different MTUs between the base layer and the container layer. And basically, the Docker in Docker daemon was spinning up new containers with 1,500 MTU, that is the default. But in the underlying network, it was 1,430. So we were losing sometimes some packages that packages are not important, like the TLS handshake is not a problem because you can recreate, but if it's an important header, your build gets stuck, basically. But never mind. You will tell me, yes, you are providing everything to your users, but you told me that you are providing them freedom to install new plugins. What happens if you install a new plugin? And that plugin requires something to be installed in the slave. Who needs to take care of that? The teams. So what we are doing is having a special slaves based on their own images, and we call them the incubation slaves. In those slaves, the teams can install their own stuff and have it ready to be used in their instance. So how this custom slaves works. Whenever they want to do something special that is not covered in the base slaves, they go to the Jenkins slave image-based repository, and in this repository we have the master with the Docker file that we use to build the base GNLP image. It's a fat slave right now, but you can have several ones. And we also have different branches for each team that we have deployed into the Kubernetes cluster. So we create the JWall branch for the new team based on the master branch. This automatically generates a build in the Jenkins lore to build a new slave. Whenever the teams wants to install a new tool, they'll just go there because they have privilege to modify only the branch belonging to their team and add the new stuff. It's built on the Jenkins lore to keep governance and see what is happening in our slaves, but the teams can access and see how it's going the build. After the build is complete and is updated to the Docker registry, the image is ready to be used in their instances. So they can install a new plugin, install the components in the incubation slave, test that everything is working for them, and create a pull request to the master one, because we don't want to everything go their way. We also want that if something is meaningful for the company, we want to include in the base slave. But with this process, we are allowing each team to include new features while not breaking the other ones. They can create the pull request, and we can follow this 2 weeks review to verify that everything is working properly, and then merge back into the base slave and make it available to the rest of the teams to benefit from them. And patching. I think I have time. So I want to spread a change across the company. Let's say that the credential to access the Kubernetes cluster has changed, and I need to update the Kubernetes plugin in each of the instances. How we do it? We just have this repository, and in different branches or different tags for each change set, we just place there an XSL file with the same name as the XML file that we want to modify. We put there the change. And using the Jenkins lore, we trigger a job that is able to modify the files in the other repos. And it has 2 different ways of doing so. One is if there is an XSL file, then go to the XML and apply the change. And if the file in the change doesn't exist in the repo that we want to modify, just add it. So we go to the pipeline job, we select which instance we want to modify, and which branch of the repo in this instance we want to modify. And I think you can imagine why, because that way we can have different versions of our Jenkins master running in different namespaces, even in the same namespace, but with different names. So we can test changes without breaking the running one. We just need to select the change set, that is the name of the branch or the tag in the change set repo. So we just select the cluster change, and we have these 2 options, that is verbose and dry run. Verbose is because I want to see what is going to happen when I apply the patch to my repo, and dry run is because I want to see what it's doing before I actually apply the change to the repo. So then I have a way to test what is happening. So I run with dry run and verbose. It's a pipeline. We are downloading the tools. Which tools? Acid tools. The acid tools is the core of all this stuff. And after a while, we are waiting for the new executor. Remember, everything is happening always in the same cluster. We are not using an external instance. So we are downloading the images, checking out the repo, checking out the change set, and applying the change set. And finally, we can see at the end, for example, we were modifying the credentials file in this case, and that is the output for the modified file. If we feel comfortable with that, then we reply the job, removing the dry run command. And that is basically what we did. If you have any questions, I will be more than happy to answer you. Yeah, please. Sorry? The users to apply, so the question is how the users update the plugins in their instances, correct? Yeah. Yeah, so that's essentially that's the idea, that they can do that. So they can go there and update the plugins. And we have cron that is synchronizing the list of plugins with the version of the plugins with the repo. So although they are making changes, we keep track of what it was installed in the instance and when. So if something happens, you can just roll back. And in worst of the cases, we can just delete the complete namespace and create the instance with the exact commit in an exact point of time. Okay, that's answer your question? Yes, please.
How many masters do you manage with this solution?
Actually, we have up to 15. 15. But we are opening it and more. I mean, the NPS from the users was so good that whenever someone has now a problem, because we still have the old one. Okay, there are still people in the old one, but whenever they are facing some kind of problem, they are always asking for, I want a Jenkins as a service instance, because we are providing them the freedom to do, and is behaving. So they just want. So we expect to have more and more at the end of the year. So. For each one of the pods, you mean? Yeah, you have different ways to do it. In one side, you can limit per namespace the amount of memory that each namespace can consume. We are not doing that right now because we have a cluster big enough to take all the workload that we have. And we want that if there is a team that needs a lot of memory and cores in one point of time, they get it, and when they don't need it, they release it. But we are setting some kind of control using the Kubernetes deployment YAML to set the resource that they can get. But that is being done with the Kubernetes thing, like limiting the resources that they can take from the cluster. Yeah, sorry. So Mac agents is a challenge. We are looking into ways of Dockerizing Mac images. It's not so good, but what we are doing for that is providing them the possibility to connect JNLP agents defined statically for each instance. Because at the end, it's like another instance for Jenkins where you can go, create a permanent slave, provide the secret and connect from the outside of the cluster. Not one that I know it's behaving properly. But in the moment, the idea is, in the moment that we have something that we can Dockerize and put into a Kubernetes cluster, let's migrate. So Docker image, you are asking for Mac images, but you can ask the same for Windows images. So the idea is, if we can take the system Dockerize and put inside the Kubernetes cluster, let's do it. If not, let's do it in the way that you are doing right now, that is having machines dedicated that you can connect from the outside. You're welcome. Yeah, sorry.
You're giving too much freedom to the developers, and I think that's okay, but how you control what is going to production, if the pipeline is correct, if you need to meet some compliance, how do you guarantee that it's following the process?
Yeah, so we are giving freedom, but we are also keeping the governance. So at the end, each instance is managed for project admins. It's not managed directly by the developers. We have admins that need to take care of these things. And we are also providing shared libraries where we define the pipelines and we tell the users to do so. And at the end, you need to trust also your developers. So we are setting another mechanism like security scanning on the images, the notary for syncing the images, and these kind of things that you can put there. And at the end, you have someone that controls the admins that check that the developers are doing things properly.
So you're deploying to production from the 15 master?
Yeah. So any more questions? I think, yeah, still 2 minutes.
Are the asset tools that you mentioned available online somewhere? Is it open source?
The assist tool, yeah. I mean, it's not yet released, but we are about to do so.
Will it be on GitHub? Adidas?
Yeah, it would be in the Adidas GitHub. Yeah. So, by the way, we are going out of time. Thank you very much. I hope you liked the presentation. And if any one of you have any questions, just come to me.